Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900 tonight. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, let's localize the landing star 9 in the cockpit for the takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Simulator X. I'm going to start showing you the cockpit instruments that displays and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. The displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb descent of the aircraft in 10 feet per minute, or the steepness of the trigonometric angles and decrease in climb descent. We have also the artificial horizon with the attitude indicator, the pitch ladder in degrees and the back angle in degrees. We have also the Lszh localizer, the instrument landing system of the airport runways we use for takeoff and for landing. So we have the threshold antennas in its runway that transmit the radio frequency that we receive from the onboard antennas of the aircraft, and we can align the aircraft with the horizontal localizer and also the vertical glide slope, the angle of approach. So we have to tune a separate radio frequency each time we take off or land in a different runway or airport, and also set a magnetic north pole heading for the runway heading. So we have also the Lszh localizer crossbars in the primary flight display. We have the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode annunciator with the autopilot and the autothrottle. Later on vertical navigation modes, we have also the HSI that displays the magnetic heading and track. Also the integrated display of the flight plan. We're gonna create using the flight management computer. Later I'm gonna show you how to create a flight plan using the flight management computer over here. You can see the primary flight display with the flight mode annunciator and also the HSI here, the navigation display. Here the engines indications, over here the ACAS, the thrust levers, the flaps and the splots, and the speed brakes, and also the horizontal trim stabilizer. Here and here we have the horizontal trim switch for the horizontal tail elevator, and also the fuel control for the engines. Flight management computer, the mouse pad for the for the flight management computer, the autopilot flight director system panel, the overhead panel. So I will show you all systems one by one before we go into takeoff. So you will see using the flight management computer later here, we're gonna create a flight plan. It's gonna be displayed in the primary flight display, as you're gonna see over here, in the HSI, and also in the navigation display, the horizontal component, also the vertical component. So you can see the airspeed, the altitude, the vertical rate of climb descent of the aircraft, the pitch ladder. Here the flight director. So I will talk to you about these instruments. So we have also the navigation display. The navigation display that displays the GPS position of the aircraft, the magnetic north pole and the geographic north pole, and magnetic variations depending on where we are in the world. We have also the terrain and weather reflections from the weather radar. You can see the terrain displayed with a red, green, yellow or amber color indication depending on the distance the terrain is away from the aircraft. Also, if the aircraft is above or it has above the terrain, or it has the terrain in an angle in front of it, it will display different colors like red, yellow, amber and green, so we can understand how far away the terrain is and how above the ground we're flying. Also is displayed in the navigation display in the vertical display system. So we can see also in the terrain mode, we can see the lakes, the rivers displayed with blue. We have the airports displayed with a 4-letter account name, its airport code name, and also the location where is the airport, how far away it is from the aircraft right now while we're flying. So we have the coordinates and also the 360 degrees view of the terrain map. We can navigate the aircraft when we're flying. We can use also in the terrain map. We have the airports. We have in each airport we have the runways and the taxiways, so we can see the runway length we're gonna use for takeoff and for landing. Over here we can see the taxiway, the runway. We're gonna see it later. I'm gonna show you from the GPS. Display the runway in the navigation display, and also the taxiway. We have also the runway length and its heading. We have also the navigation aids, the nav aids, the workstations, ADFs and DBs, the waypoints which are horizontal and vertical navigation fixes, and altitude and airspeed constraints. We have to fly through some waypoints, as I already explained to you. Using the flight management computer, we're gonna create a flight plan. Later, you're gonna see the purple or magenta line of the flight plan over here from the flight management computer is gonna be displayed in the navigation display in the HSI. Also, when we connect the autopilot and flight director system panel in a later state of the flight, you can see autopilot engaged, disengaged. We have the LNAV and the VNAV modes, the airspeed guidance, the heading guidance, the vertical rate of climb descent of the aircraft, the altitude select, the flight director on and off, and the auto throttle, arm and disarm. So we're gonna select all the modes here. You're gonna see how we're gonna use the autopilot panel. When we connect, it's gonna follow the flight plan we're gonna create using the flight function computer. This purple horizontal purple line, also vertical in the LNAV and the VNAV modes, the lateral navigation and vertical navigation modes. Also in the navigation display, we can see other aircraft that fly around our own aircraft using the transponder, the display and ADC transmitter receiver. The transmits our radio frequency to other aircraft and the air traffic control and receives from other aircraft. You can calculate within this computer the other aircraft distance from our aircraft in nautical miles. You can calculate up to 40 nautical miles or 72 kilometers. So it will show us the aircraft distance from our aircraft, and also its bearing depending to the aircraft, and also you can calculate how many hundreds and thousands of feet the other aircraft is above or below our aircraft when we fly. Also display the other aircraft with the diamond shape with the altitude difference next to it. Also with an arrow if they are climbing or if they are descending, arrow up or arrow down. So you can also calculate whether they climb or descend with respect to our aircraft, the other aircraft in the air. Also you can calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TICA system, the traffic collision and advisory system of the aircraft. To make an avoidance maneuver, you have an incoming collision with another aircraft. Also in the ground you can show us the other aircraft in the runways and the taxiways, the same way like in the air. So this is the TICA system and the transporter. We need for flying IFR, instrument flight rules. So you can see here we have the cockpit, the outside view of the aircraft. I will show you also, and I will talk to you about the flight controls of the aircraft. So we have here. So you can see here we have the flight controls of the aircraft, also the computer that I use, the mouse pad, as you can see, to input all the data. Also from the keyboard, I need the mouse pad for the flight management computer, the autopilot, also the switches over here and here, the radio management panel. Also we have the flight controls. So you can see we can climb and we can descend. We use the side stick, the Logitech Extreme 3D, which is identical to the Airbus side stick, as you can see. So we can climb and we can descend. You see the yoke of the Boeing 787 is moving back and forth when climb and descend. Also to make turns left and right, we use the ailerons and the spoilers, the control wheel in the Boeing aircraft of the yoke. Also we have the rudder pedals. The rudder pedals we use for controlling the vertical rudder, vertical stabilizer rudder, and also the nose wheel steering. In the ground at low airspeeds we have also the tiller in either side. Also rudder pedals in both sides, as you can see, are interconnected and move together. Both in Boeing and Airbus aircraft have similar design. So you can see here also the outside view of the aircraft. So I will talk to you about So we'll talk to you about Newton's physics, aeronautical and aerospace engineering, and aerodynamics. We need to know for, and also the Bernoulli theory of fluids. We need to know for the air transport pilot license and the commercial pilot license, the ATPL theory and CPL theory. So I will show you the aerodynamics and the flight dynamics of flying an airplane. We need to know, so I will show you the outside view of the aircraft. Also I will explain you how to use the same moment the flight controls. So after showing you all these systems of the aircraft, in the end part of the video we'll make an engine start demonstration, setting up the flight management computer, the autopilot flight director system. We're gonna make a complete flight from takeoff, climb, cruise, and approach and landing, full manual. Maybe we're gonna use some autopilot for display in the end part of the video. Stay with me. So we can see here the outside view of the aircraft. You can see the surface area of the wings, hold the weight of the aircraft when we fly. So the weight is divided over the surface area of the forward wings that hold mainly the weight of the aircraft that produce the aerodynamic lift. When we fly, the airflow is producing aerodynamic lift. We have higher pressure below the wings, which lifts the aircraft weight and acts over the weight of the aircraft downwards. So we have also the thrust from the engines. We have the jet engines here because the jet aircraft that move the aircraft forward. The thrust from the engines overcomes the drag from the skin friction of the aircraft. So we have also, you can see here, so we have higher air pressure when we fly below the wings, which pressurize the aircraft weight and width up into the air. Also we have lower pressure above the wings, which sucks the aircraft weight and width up into the air. We have the engines, you can see jet engines here. So we have the components, you can see the high pressure compressor and turbine in the back section in the middle of the engine cycle. So we have high speed starter and shaft, high pressure compressor and turbine, also the combustion chamber over here. We have the fuel flow from the left over here, the long high pressure fuel valves and the fuel lines and the fuel booster pumps here, the fuel tanks are left for the left wing. Also for the right wing we have the fuel lines over here that move down the engine. So we have also the forward side, we have the front fan, also with the bypass air. You can see the bypass air is this round circle over here over the high pressure turbine. So we have two different airflows, one higher speed, one lower speed. So we have the jet blast from the engine, from the exhaust cone over here. So we have also the low pressure compressor and turbine and the low speed starter shaft over here. So this is the main components of the engine. Also we have the wing and engine RDIs, the flow of hot air for the RDI system over here in the front. Also we have the mean aerodynamic chord over here, the Mach, which is 23% of the mean aerodynamic chord, where the maximum aerodynamic lift occurs in the forward wings. Is also position where the center of pressure is moving back and forth when we fly in the wings. Also we have the airflow becomes detached from the top surface of the wings when we fly, and the airflow we have the stall of the wings for a given angle of attack and airspeed that is changing. So we need to monitor over here to avoid the stall of the aircraft wings. We need to pay attention here in the primary flight display. As you can see, we have the airspeed indicated all the time when flying. In the primary flight display, the airspeed tape, so you can see the minimum airspeed indicated right now. Also we have the stall speed with a red and yellow rubber color below the airspeed. Also this gives us the angle of stall, the 1G stall angle in flight. So we need in the Airbus we're gonna move the side stick forward or the yoke forward to lower the angle of attack of the aircraft, and also apply thrust forward to increase the airspeed. This is the move for the stall avoidance in the air. So we need to avoid stalling the aircraft wings. So this is the mean aerodynamic chord. Also here, as I told you, is the fuel left and right wing fuel tank. Center tank is the center of gravity through the main aerodynamic cord approximately. So where is the center of gravity? Also we have the yawing axis through here, which acts over the rudder of the aircraft when flying, or also in the ground when we take off or when we land. We use the rudder for control at high airspeed. So at low airspeed, when we start the takeoff, initiate the takeoff, here we have the nose wheel is also used for controlling the forward, the directional control, the going of the aircraft. So for that I have the size here mapped, the rudder pedals, so you can see. So we move the rudder pedals, left rudder and right rudder, and also is used for the rudder pedals are used for controlling the forward nose wheel steering. So you can see both sides are interconnected, move together, and also for the nose wheel steering, and we have the tiller also for the nose wheel steering here and here. So you have also the toe brakes, you can press the top surface of the rudder pedals, you're gonna brake. So we have here the rudder used for directional control, also simultaneously with the nose wheel when we take off from 0 knots up to 45 knots, like 72 kilometers an hour. The rudder becomes aerodynamically effective. So from 0 knots up to 45 knots, the nose wheel is deflected from the computer automatically up to 76 degrees, either left and right for directional control alongside with the rudder. Also, as we increase the airspeed above 45 knots or 72 kilometers an hour, where the rudder becomes aerodynamically effective, the forward nose wheel is decreased from the computer, its deflection is decreased from the computer automatically. You don't need to do nothing, from 76 degrees to like 7.6 degrees. Then as we accelerate for takeoff at 18 nautical miles per hour or 144 kilometers an hour, the forward nose wheel from the computer is going to be locked to 0 deflection or a small deflection like 0 or 1 degree. So we have only the rudder above this airspeed of 144 kilometers an hour or 80 knots. Also, when we land, it's the inverse. With touchdown, we have first the rudder to control the aircraft, and as we slow down below 80 knots or 144 kilometers an hour, we have the nose wheel back coming in for directional control and increases in directional control. So we have, so this is the rudder pedals, what they do here in the aircraft. Left and right turns, directional control in the ground, also in the air, the rudder, and the toe brakes. We have also one more axis here from wingtip to wingtip, is the pitch axis in the Airbus aircraft or the Boeing, both of them. So in the Airbus you use the side stick, pull up or pull down, back and forth. For climb and descent you move the elevator surface. Also we have the trim of the elevator or the horizontal stabilizer surface when we fly to balance the aircraft. So some of this is automatic of the trimming. We have auto trim, we don't need to do nothing to trim the aircraft. So we can apply manual trims. So we climb and descend, we take the weight up and we take the weight down. We climb or descend, very easy. In the Boeing aircraft, the pitch axis here is the yoke back and forth. Is the side stick back and forth in the Airbus. Same flight control, no difference, no in the air. So you use the control column, the vertical yoke part for back and forth. So you take the weight up, you climb, and you take the weight down, you descend, very easy. And also you have the horizontal tail trim elevator. This switch I'm gonna show you now in a couple of minutes. You can use here in the alternate switch to control the elevator trimming. So we have an aircraft coming in for landing over here, as you can see. Just touched down. So we have also the flight controls, climb, descent. We have here, as you can see, one more axis is the longitudinal axis from nose to tail. So this is what we do in the Airbus or the Boeing. You roll the aircraft left and right turns. You use in the Airbus the side stick left and right turns. You move the ailerons and the spoilers. like this, so you create aerodynamic lift difference between the left and the right wing, more lift in the one wing, less lift in the other, so you make a turn in the air, you roll. And also in the side stick left and right in the Airbus you have ailerons and spoilers. In the Boeing also you have one more surface, you can see the flaperons here and here. So you have the ailerons here, the spoilers, air spoilers and flaperons in the Boeing. Also you can see we have the speed brakes fully extended, all flight spoilers, and the flaps also are fully extended uh, with the slats also. So I'll show you also this. So when we climb and we descend in the Airbus, climb and descend, also we make turns left and right. Control wheel in the Airbus is in the side stick in the Airbus is the control wheel in the Boeing, like this. So you make left and right turns in the Boeing using the control wheel, very easy, same like in the Airbus. You see the deflection is similar, there's no difference for making turns. Also both are fly-by-wire aircraft, both the Boeing 787 and the Boeing 787 and 777 and the Airbus aircrafts. So they have flight control computers over here. So this is control wheel, left and right turns, ailerons and spoilers. So here ailerons and spoilers. Also we have the elevator, we have flight controls together, coordinated flight. As you can see also from the inside, you can use all flight controls together for coordinated flight, or use separate. Also in the Airbus we have the side stick priority button to take either side stick, or you have dual input when flying. We have the push to dock button and the autopilot disengage. Also the Boeing, both sides are interconnected and move together, as you can see, the yoke and the control wheel. So you need to override either side. If you have a failure, for instance, you need to apply some force from either side in the Boeing aircraft. Also the rudder pedals, both Airbus and Boeing, are interconnected and move together in all functions. And also the Embraer and CRJ aircraft are quite similar with the Boeing yokes and horizontal trim stabilizer and rudder pedals. So we're gonna see now. So this is most for the flight controls, I believe. I will show you one more view now of the flight controls over here. So one more view of the flight controls, and I will show you inside the aircraft the rest of the systems. Oh, I need to show you also the horizontal trim stabilizer. Over here, maybe I'll show you the horizontal trim stabilizer, how to trim the aircraft in the air. So we need to see the horizontal trim stabilizer, see part of the flight controls. So we have again the view here, as you can see, the cockpit and the computer I use, the flight controls here and here. So we're gonna have here the side stick line in the center like this. One more view. So we climb and we descend. We make turns to the right, turns to the left. So you can see the side stick is identical to the Airbus, and all the movement of the flight controls for climbing, for descent is identical. The side stick deflection is proportional to the yoke deflection for climbing, for descent. Also make turns to the left, turns to the right, as you can see. So hope you like the flight controls of the Boeing 787. The way I show you the side stick that I use. Climb the descent like this to make turns left and right. So we have also the thrust levers over here. We can actuate the thrust forward and up. Over here, increase and decrease the percentage of the engine thrust needed when flying. You can monitor here in the ACAS in the Edge Education and Crew hardware system display. So we have the horizontal trim stabilizer also, rudder pedals, nozzle steering and rudder. So this is all flight controls. Also the side stick, the Airbus side stick, hope you like. So we'll show you also the outside view now, a little bit with this view. So we can climb and we can descend, make the rudder, left and right turns, sidearms, and spoilers. So left and right turns, sidearms, spoilers, flaperons, and the Boeing. Very easy, very fast, as you can see. The side stick movement and controls deflection. Very responsive. So I believe this is all for the flight controls. Tonight I will show you the rest of the systems. Also the horizontal trim stabilizer. And the flaps and the slats and the speed brakes, which is also part of the flight controls, as you can see. So we need over here. So I will show you the horizontal trim stabilizer. So we have the horizontal trim stabilizer here. You can see we can trim the elevator up and down like this. You can read the tag. This is for trimming the elevator of the aircraft up and down, as you can see here, to control the aircraft when flying, the balance in the air. So we can trim the elevator up and trim the elevator down. The autopilot disengages the head of the clutter and move the yoke on the descent to apply some balance. Also control wheel. So we have the elevator trim. Again, you can see the tag, what it says. Maybe better view of the tag here. So this is elevator trim. Left click down, right click up like this. Yeah, you can read that now. Left click down, right click up. So when you trim the elevator up, you pitch the nose of the aircraft up, and when you trim the elevator down, you pitch the nose of the aircraft down. You have this aerodynamic effect. Elevator trim, left click down, right click up, as you can see. So with trimming like this, I use the mouse. Elevator trim, left click down, right click up. So we balance the aircraft when flying like this. You can see how many degrees you trim the elevator over here in the screen, the ACAS and indication across the system display. So we have also the head-up declutter over here, some double switches, and the autopilot disengage the small switch. This is more important for flying manually. The elevator trim, also the flaps limit over here. We need to know. So we have the elevator trim position when trimming. Now it's 4.75 degrees. It's also balanced with the flaps rudder trim we don't use right now. Is 0 position. Rudder trim, stabilizer trim 4.35 degrees inside the green band is set for takeoff. So I'm gonna show you also the other information in the ACAS later. So we have also horizontal trim stabilizer, the alternate channel over here, so we can trim the elevator up and down like this using the alternate trim switch like in the Embraer aircraft. For the Boeing 777 we have the trim tab here in this panel. So this is the alternate, as you can see, elevator trim, left click down, right click. Also we have the parking brakes, and disarm. We have the cutoff switch over here. Open this and disarm the switch from normal to cutoff. This is for the auto trim function of the Boeing aircraft, Boeing 787, Boeing 777. So we have here, as you can see, in the overhead panel we have the flight control computers. In the auto position, primary flight control computers, if we have a failure of the hydraulic system over here that will affect either the left or the right horizontal trim, stabilizer or elevator movement. You can see left and right engine driving electric C1, C2. We need to come down here. We're gonna have the grid. We have the normal, the alternate in direct mode, and also the mechanical backup. We're gonna have a degradement of the flight control computers. So we need to come down here, and you see this is for all Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777, and Boeing 787 aircraft. You open this from normal to cut off this switch over here, as you can see, either the left or the right horizontal trim stabilizer or elevator trim. So you can read the cut-off switch over here, as you can see, and then you use only you disarm the auto trim function like this, and you use on the manual trim switch like this. You can see nose up and nose down, pitch trim. This is other separate radio communication panel here. So we're gonna lose the auto trim, we're gonna lose the autopilot like this, losing the auto trim, the automatic trimming of the aircraft. So you're gonna have to fly the aircraft manually like this, and use the automatic, the manual trim switch or the alternate trim switch here. So you can see it's a fly-by-wire aircraft. It has its flight control computers. So the Boeing 787 it has a flight control computers, like the Airbus has flight control computers that control the aircraft movement, flight controls in the air. In terms of acceleration of the G gravity, where 1G is the Earth acceleration. So you can see here we have another aircraft photo for landing. So you can see here it's coming in, as you can see. Need just touch down. So 1G is the acceleration of the Earth gravity, and we maintain stability in the air with the Airbus aircraft. I'm gonna show you now the seismic climb 30 degrees or 1.5 G in climb rate. Also when we descend with the Airbus aircraft in normal mode, we have minus 15 degrees or minus half G, maximum deflection plus 30 or minus 15. Also we can make a maximum seismic deflection in the Airbus 67 degrees if the left and right. And also when we release the seismic, it goes back to 33 degrees automatically, and then we have to move the seismic to come back to level flight using the flight control computers. Also the flight control computers act for alpha protection mode when we reach the 1G angle of stall that I told you also in the Boeing aircraft. Velocity lowest selectable and maximum velocity. So we have speed limits and speed protections, and the G limit. Also when we fly level in the Airbus aircraft, we have 1G acceleration vertically through the axis of the aircraft to maintain using the auto trim, the horizontal stabilizer, and the other flight controls. Also the Boeing has similar features. So it has the flight control computers, and as I told you, if we have a degradement from the hydraulic failure, we need to disconnect the horizontal trim stabilizer over here, and we're gonna lose the auto trim function. So use only the manual trim switch after. So this is most of the flight controls. So I'm gonna show you the flaps and the slots, the speed brakes, the displays here. So you can see here we have the fuel control for the left and the right engine, fuel run, the fire extinguishers for the left and the right engine, the transporter, the radio communication panel, the radar trim over here. So we have here the VHF radio, data satellite with a radar. So we have the thrust levers, the left and the right engine thrust lever, the auto throttle disengage and the takeoff go around, the thrust reverse for the engine. Also you can see the flaps position. We can extend or retract like this. So this way we retract, this way you extend how many degrees you need for takeoff or for landing. The flaps that increase the surface area, and here the speed brakes. So you see the flaps over here, position, land gear also, extend and retract, this handle over here, the alternate gear, the lock override, the retract speed, the standby instrument here, the auto brake position, you can see auto brake for ejected takeoff like this. You will see auto brake RTO displayed in the ACAS. Also disarm off for landing. You can use auto brake 1. But right now we need to be in landing configuration. So we have auto brake 1. So this is the landing gear. This is the horizontal trim stabilizer, the radar trim. Also you can see the engines indication, left engine versus the right engine. You can see the N1, which is the low speed starters, have low pressure compressor tube and the turbo fan towards the engine left and right. This is the red, yellow, red, green limits. The takeoff limit 99.2% with 2 degrees total temperature. The exhaust gas temperature per engine in Celsius degrees. The N2, which is the high speed starters, have high pressure compression tube and the turbo fan towards the engine. The fuel flow per engine per 1,000 kilograms, so thousands of pounds. So the pressure, oil temperature, oil quantity over here, and the vibration of the N2 stage of the engine. So right now we have thousands of pounds for the fuel flow, gross weight, total fuel on board, and fuel temperature. It's gonna freeze in flight. We need to recirculate. We have the radar stabilizer trim and the cabin pressurization that admits also pressurized air from the engines. You can see the cabin altitude as we climb in with descent. The aircraft we need to pressurize, open the outflow valves or close it in the manual mode, the automatic. It's done by the computers, you don't need to do anything. So when we climb, right now we are 1,400 feet above the ground. When we climb, you can see the rate. The differential pressure is going to be 7.8 psi inside the cabin. It's going to be having higher pressure than outside. And also at 45,000 feet altitude, we're going to be having cabin altitude of 6 or 7,000 or 8,000 feet maximum. So this is the cabin pressurization system, the outflow valves position also here in the overhead panel. As you can see, this is pressurization. I will show you later. You can see it's in the same section with the pressurizer from the engines and the APU. We need pressurizer for this system. So I'm gonna show you also the other displays before I show you the flight management computer, primary flight display, navigation display over here, autopilot. So in the navigation display you can see the airports. So I'm gonna show you now the flight management computer. I'm gonna input all the data we need for this flight using the flight management computer and create a flight plan very fast. We have a few minutes left. So you can see I have the mouse pad here to control the data, and also the keyboard I need, and the screen over here. So I'm gonna use this screen over here, and you can see the mouse pad. I can use the touch screen of the mouse pad and select the displays. We have the keyboard, primary keyboard, also the display here, the CDU. So you can use index, for instance, identity, position, performance, takeoff, approach, enunciate status over here. Also flight plans, load a traffic control route. So we have all the data we need for flying the aircraft. I'm gonna show you this view of the aircraft. Flight management computer, the control quadrant. Also you can see the engines from the top and the autopilot displays. So you can see identity over here, position, performance, takeoff, approach, and annunciate status. So we have the identity is Boeing 787-900 ZNX engines. Also the position, we use Lszh, Zurich International Airport in Switzerland. And we align the coordinates over here, Lszh. Using the inertial reference system that receives GPS, 3 GPS receivers, and magnetic North Pole, geographic North Pole alignment. With the inertial reference system, the laser gyroscopes of the aircraft, the longitude and the latitude. The performance, you can see 0 fuel weight plus fuel on board, gross weight for takeoff, the reserves 5% over here. The cruising altitude 25,300 feet over here. The cost index 100%. Fuel freezing temperature in the cruising center of gravity. So we'll fix the route first. We have Lszh from this airport, Zurich International Airport. Back to Lszh. Copy paste. We clear that and we use runway 14 for takeoff. Then we're gonna select departures and arrivals. So we have departures, arrivals, select departures, runways 10, runway 14, 16, runway 28, runway 34. So we select runway 14, and the seats, the other instrument departure, waypoints and fixes, and horizontal vertical navigation fix, not speed constraints. We use the Zui to Alpha. So we go in the arrival, so we select the approaches for the arrival. VOM 16, VOM 28, runway 28, runway 34 ILS, runway 14 ILS, runway 16 ILS, runway 28, 34 GLS 14, localizer 28, localizer 34. So we select ILS 14, trans Amiki, and trans select the stars, the star terminal arrival, weapons and fixes, Negria 1 Alpha. So we have the legs, the route is displayed with blue, is not yet activated. We need to press the execute, cancel the discontinuity over here. So this is the route for the flight plan. The autopilot is gonna follow in flight. So we have here legs, cruising altitude one more time, because we input different routes for these reserves, and we have the legs. Press execute over here, this green switch, and it activates the flight plan. Now we can use the autopilot with this flight plan. So we have the first waypoint after takeoff, the airspeed and the altitude, heading 2 nautical miles from the threshold of the runway, 1 nautical mile, 3. We make left turn, Zui, 6 nautical miles, 300 knots, 6,000 above the sea level. Make left turn, Negria, 26 nautical miles from Zui, 301 knots, flight level 22,200. Make a right turn, 12 nautical miles, 320, 11,800 with descent. Make you Zui, Zurich 701. You can see the distance and the airspeeds and the altitude, TRA, CI14. Osnem, we make a right turn, a left turn to align with the runway, 170 knots, 4,000, and the runway for landing. So we select here flaps for takeoff, center of gravity 33% or 4.85 degrees for V1, we rotate V2 for this gross weight and the runway. So we have departure, arrival, alternate route, VNAV, progress, FMC communication, hold, we can hold over a waypoint in flight, the legs. The fix, we can set a fix, also navigation radio, tune ILS, localizer, and also the VOR ADF. So we go back in the cockpit over here, we can set one more time the displays here. So you can see the airspeed indicated, the barometric altitude. We set the barometric altitude using this barometric pressure before flight, very important. During flight we have 39.9 degrees Celsius of mercury, the radio. This affects the barometric altitude and the rate of climb descent. So we have barometric altitude settings of mercury hectopascals. We can change either one. We have 1013 hectopascals to 39.9 degrees of mercury. minimum radio or barometric plan, rains, weather radar, traffic, terrain, accept, cancel, reject some warnings, the systems of the aircraft in the displays, also the flight plan. So we go over here, we set very quickly, have not much time, the left and the right, IDZ 120 200 volts, we start the APU. We're gonna need the APU to provide us the auxiliary power unit with pressurizer and electric power to start the engines, primary flight control computers in the auto position, your data computer over here, flight control surfaces over here, the battery, FD door power over here, the passenger oxygen, window sheet, also the rammer turbine, backup hydraulic if we lose system. We're gonna see if we turn off the left and right engine driving primary in demand. We have the fold, so we turn back on and then to the auto position. So we have also wing and engine on the ice over here very quickly in the on or auto position. Also the cabin pressurization here, outflow valves in the auto. In the manual we use the outflow valves open and close to pressurize the cabin when climb or descend. Also we have the bleed air from the engine and the APU we need for cabin pressurization, wing and engine on the ice, hydraulic fluid pressurization, also for the oxygen inside the aircraft when flying. So we have also the recorders, the cargo and APU fire, electronic engine control for the engine. With the auto start we can start the engines. So we have the normal and the alternate modes of the engine control for the Flught, for the Flught or the electronic control computers. So we have the fuel jettison, we can arm the switch, select the nozzles and how much fuel to remain. We have the left and the right wing and the center tank, and also the cross feed. If we turn it on, it can feed either engine with other power or either tank, and also balance the fuel between the left and the right wing. So we turn back on the fuel booster pumps, the forward and the aft. Turn off the cross feed, we don't need it right now. So we're gonna start the engines first. Also we need some lights over here for the front lights, landing lights. So you're gonna see the displays, maybe it will have some time later what they display. Your data, also the terrain, you can see the runway and the taxiway over here. So in front of us we have the taxiway and the runway, so you can see the GPS position, the taxiway, the runway and the terrain in front of us when we fly. Also the flight line, very easy to understand. So you can see the terrain, the altitude difference over here when flying. You can see the aircraft symbol and the nav commands in front and below us, also the runway and the flight plan over here. Also the center display 360 degrees. The airports, also you can see this plan display over here for navigation purposes again. So we have map setting over here. So the systems, we have the hydraulic over here, pressure APU, is running oxygen and liquid cooling. We have the electric left and right IC, the great drive generator, the APU is running. The load cell, the main battery and the APU battery, charger discharge, volts and amperage. Also we have the hydraulics, you can see left and right engine driving, primary demand, where the hydraulic fluid goes in the aircraft, which systems uses, shut-off valves, isolation valves, the quantity of the hydraulic fluid tanks and the pressure 5100 psi over here. So we have the fuel on board the aircraft, you can see left and right wing, tank 11,000, center tank 11,000, total 33,400 pounds. Also you can see here the minimum fuel temperature below which the fuel will freeze in flight, so the FAREX control automatically the recirculation of the fuel from left and right wing and the center tank in flight when we have lower temperatures in order to heat up the fuel and avoid the fuel freezing. Also the lubricant and the oil, this is the oil, the fuel transfer system. You can see minimum fuel temperature -37 degrees and the fuel temperature right now -6. Also you can see the crossfeed valve is off, internet only can feed either engine would have a pump or the tank. Low and high pressure fuel valves feed both engines from the center. Also, the APU is fed around the left wing using the DC motor, the air pressurizer for oxygen, cabin pressurization, hydraulic fluid tanks. The cabin can be pressurized here. The doors are closed, the gear. You can see the temperature of the brakes and the pressure of the tires. Flight controls, very important here, left and right turn, also climb and descend the rudder, and also the rudder trim. So this is one of the last things we need to do before flying the aircraft. We have here the FS display, see status, maintenance, and circuit breakers. So we go here, we have the checklist, one of the last things we need to do before doing the engine start. So the checklist before start, after takeoff, descent, approach, landing. Also the communication. So we're gonna start the engines. We turn off both engines here. You can see fuel transfer in the off position. So you're gonna see the engine display. You can see engines are off right now with amber fuel pumps. Also the engine is running down. So we can see outside the Boeing 787 jet aircraft, jet airliner. So we have here the engines. You can see slowing down. There's also the hydraulics are off, so we need to use the auto start here very quickly. So we start both engines, the starters. You're gonna see the yellow switches lights when we turn the auto start on. So we have the N2 is increasing. We have only pressurizer in this state right now, in the N2 from the APU admitted. So only pressurizer right now, there is no fuel. So we start the fuel control here, the fuel valves like this, both of them on. So now the auto start is on. We have the engine start. So we have the N2, N1, exhaust gas temperature, fuel flow. So you're gonna see the messages are going off. Also, we're gonna have at 62%, both engines are running, so we can go for takeoff. Flap set for takeoff, 15 degrees, speed brakes on. We need to set the autopilot only very quickly. So we have the auto throttle left and right, on and off, flight director, LNAV and VNAV. We turn off flight director like this, disarms, autopilot disengaged like this. So we set the heading here, the runway heading we're gonna set. Also the vertical speed we can set 0. You can see the minus when we descend, or plus when we climb like this. Also we can set the altitude thousands and hundreds. Also the airspeed like this. So we are ready for takeoff like this. Parking brakes off. Advance the thrust levers forward. We take the clearance from the air traffic control for takeoff. So the runway is open, there is no other traffic. We take the clearance from the air traffic control for the runway, so we go into the center line position for takeoff. So we advance here the thrust levers to full takeoff like this. You can see also here in this display. So we go. Also we can use the side stick down until 80 knots, or the yoke, and align with the rudder pedals. So we have 100 knots, 120, V1, we rotate 9 degrees, pitch 9 degrees only, the aircraft for initial rotation, not hit the tail in the ground like this. It's a good mnemonic. So the landing gear up, we have positive rate of climb like this, keep climbing as you can see. So you can see we are the airspeed is 200 knots right now, 200 nautical miles per hour. You can see the terrain around and below over here on the navigation display. So you can see we are 2,400 feet above the ground, but 4,000 feet above the sea. We have the stall speed, the wind direction speed. Over here we climb with 5,500 feet per minute, so we need to slow down the climb, pitch down the aircraft because we're gonna reach the stall speed here. Also you can see the terrain around the flight plan. Also here you can see below you when flying the terrain below you. If we look up further away, I'm gonna have more terrain right now like this. Also you can look the engines indication, the stall speed as we're climbing. So we need to start turn in a couple of seconds. So now we are over here. We have the terrain below us. You can see the aircraft is like 5,500 feet above the ground. So the ground is displayed with the green line over here, this green wave from 20 nautical miles away from the aircraft over here. So you can see again the outside. So we have the runways. We need to start turning now. So we start the turn for the flight one. Full thrust here. And we have 13 more minutes left for this video to end. You can see the runways here. So we keep climbing. You see the flight plan, also the outside view. So this is a beautiful view of the aircraft of the Boeing 787 as we climb and have this beautiful view. So we keep climbing. Make a small correction here for turn. You need to follow the flight plan. So you can see the view now where we are located, having the Switzerland around, the lakes and the Boeing, the Germany, my homeland here. We're gonna be overflying very close to the Germany. You can see the aircraft after takeoff, everything is safe. So you can see the airspeed 169, the slow speed, the wind is 24 knots. The next waypoint we have to fly through. We're gonna be having the Zui anyway. Quite fast, clear, discontinued. So we're gonna be having also a line with the flight plan. Again, also the Zui waypoint. So we use some right rudder here for this right turn. So maybe we can connect the autopilot if we need. You can see the first waypoint, the Zui, and we use the auto throttle, the pilot, first fusion, second one, also decrease the rate of climb. Use some flaps up, increase the airspeed also. So now we're flying with the autopilot, as you can see. Autopilot is engaged over here. So we can make the turn now over here. So we're gonna start the turn over flying this beautiful area. The Lszh, Germany, my homeland, Bayern Munich, and France. So we're gonna have over here press the execute. We're gonna be flying over this waypoint over here, then make the turn back to home, as you can see. So now we're flying with the autopilot. I use the input from the side stick, as you can see. Also we can use over here so we take the turn here. You can see the Switzerland, beautiful view, also the Boeing 787. The Lszh, Germany, homeland, and you can also use manual flight controls for this, allowing the aircraft faster. So now we can fly a little bit manually, as you can see. So we use the trim also, left rudder, right rudder right now, to align with the flight plan. So use manual inputs again, connect the autopilot whenever we need. You're gonna see autopilot engaged. So we have the beautiful view here, overflying. We're flying manually, as you can see. Have the galactic view. We're gonna start the descent now of the aircraft. So this is the Lszh, the France over here. So we start the descent right now, as you can see. Speed brakes on. So we start a manual descent like this, idle thrust, and have 5 more minutes to follow over here until the landing. We are overflying the airport already, this area, so we are descending like this. Keep descent rate, idle thrust over here. So you see the aircraft again as we descend, the cockpit. So the airspeed indicator, the descent rate right now, we're following the waypoints as you can see. Also the other side view, the autopilot said over here we need to change the airspeed a little bit. So we keep descent, also align over here with the flight line as we see. Keep descending. Make the turn over here. And we have 3 more minutes left for the aircraft to land. So we align here a little bit as we are descending, and then we start again full manual flight. Also left rudder pedal right now as we are descending. So we need to be aligned here. So we are in the runway, as you can see. We have to be aligned with this line, as you can see. Also the outside view, we're gonna be approaching for the autopilot landing, for the manual landing actually. So we need to be aligned here. So we fly manually, as you can see. Add some airspeed like this, as you can see, and our approach land configuration. So we're gonna be having the landing gear down, flight controls. We have some side wind, some wind gusts over here. Also the flaps down like this. So we're going manually right now. You can see we have the Lszh also localizer aligned with the runway center line like this. For approach and landing, we have a few minutes left, maybe a few seconds. We have the Lszh localizer here, as you can see, to follow all the indications. Also in front of us, as you can see, we fly manually. Some side wind, some wind gust. We use all flight controls for align with the runway. We're gonna have some side wind and some wind gusts and some thrust. For the touchdown, we're gonna be leveling off, align with the center line and level off for the flare. So we have the flare down, flare and touchdown, very beautiful. As you can see, align with the center line. Also parking brakes, idle, thrust, as you can see, and thrust are reverse, full thrust reverse. So we're slowing down, as you can see. So this is slowing down. Also you can see all the landing gear, the nose wheel, it's perfectly safe, the thrust reverse. So we use idle, thrust reverse.